Welcome everybody. Let me introduce myself first. I am Mr. Yoganand Samant from Kuda High School, Kuda, District Sindhudurg. My register number is C072 and topic of presentation is coordinate geometry. Observe and explore. Student, let us observe carefully the following video.
In this video, let's discuss what is coordinate geometry and why should we learn it. Let's see what is the key concept behind coordinate geometry. With the help of coordinate geometry, we can represent a point such as 5,7 here, or we can represent collection of points such as this line or this circle. Let's see what is the key knowledge we get by learning coordinate geometry. With the help of coordinate geometry, we get the ability to precisely define the position of objects in space and time. For example, let's see the first sketch. It shows the relative positions of park, school, post office and Jordan's house. Here, if we fix the position of school as the point where we stand, with the help of this sketch, we can find the positions of post office, park and Jordan's house if we know the distance of these places from school. Let's look at the second figure. What is this? This is map of India. Suppose in map of India you want to find the position of a place, let's say Delhi. Then we need only two informations. One is longitude and the second one is latitude of Delhi. Similarly, coordinate geometry can be applied in context of 3D and 4D, about which we will learn in detail later. Now let's see what are the key benefits of being precise in defining the location of points or objects. First, let's see the benefits in medical science. An ECG, that is electrocardiograph, helps in measuring the variations in heart, and an echocardiogram helps in finding the blockages, or if there is a hole in heart, it helps in finding the size of the hole. Next, let's take research in space, science and navigation. How do we calculate the path for space missions such as Mangalyaan? We use coordinate geometry for this. Our ability to precisely define the positions of Sun, Moon and Earth at a time helps us in predicting solar and lunar eclipses. Also, coordinate geometry helps in navigation and long-distance travel. Now let's see how coordinate geometry helps in technology. Coordinate geometry is used in designing aeroplanes and other complex structures which involve complex designs. Coordinate geometry is also used in animations and video games. It is also used in navigation using maps and GPS. Let's summarize what we have learned in this video. Coordinate geometry helps us in defining precise position of object or point in space and time. Coordinate geometry finds applications in navigation, in understanding direction to reach a particular location, in medical science for diagnosis and treatment, and in research in space science and technology.
In this video, you might learn what is the use of coordinate geometry in our daily life. Now let us learn the terms in coordinate geometry. Define and prove. Now we have learned from this video which observed by you that one of the use of coordinate geometry is to determine the exact location of any object in the plane. So I take here a plane and divide it into vertical and horizontal lines grid. I made equal tiny square in this plane. That is, I divide this plane in equal tiny square of 1 centimeter square each. Now again I divide this plane with two perpendicular lines. One is horizontal and other is vertical. Two lines are perpendicular to each other. We took these two lines as reference lines. These are called axes. The horizontal axis is x-axis and vertical axis is y-axis. The intersection of these two axes is called as origin. So because of these two axes, intersection of two axes, the plane is divided into four parts. You can see here the first part is known as first quadrant, second one is second quadrant, which is upper left, then lower left part is third quadrant, and lower right part is nothing but fourth quadrant. Any point in this plane will be located at first quadrant or at second quadrant or at third quadrant or at fourth quadrant or on x-axis or on y-axis. To represent any point in the plane, we here further we did make parts of this axis, equal parts of this axis, in such a manner that from origin the right hand side x-axis is divided by 1, 2, 3, 4, 5, 6, 7, 8 and so on. At the left hand side we divide as -1, -2, -3, -4, -5 and so on. Similarly, y-axis is partitioned as on upper side of origin 1, 2, 3, 4, 5 such as positive numbers, and downwards from origin -1, -2, -3, -4, -5 such as negative numbers. Now let us see how any point can be represented in this plane. So take any point here. To locate this point, we draw perpendicular line on x-axis, which will give us the x coordinate of this point, and perpendicular from this point to y-axis, that will give us y coordinate. Here the perpendicular on x-axis from this point lies at 4 on x-axis, so the x coordinate is 4, and perpendicular on y-axis lies at 5, so the y coordinate is 5. So we can write this coordinate as x coordinate first and afterwards y coordinates. So the coordinate of this point will be 4, 5. Similarly, we take second point perpendicular on a x-axis lies at 8, so x coordinate is 8. Perpendicular on y-axis lies at 2, so y coordinate is 2. So coordinates of this point will be 8 and 2. Similarly, take this point here, a red point. The coordinate of this point, can anybody tell me? Correct. It is -4, 0. Now we will take one more point here. Can anybody tell me its coordinate? Correct. It is 2 and -3. Now the question is arise, how can we determine distance between 2 points? For this we take first 2 point, distance between these 2 points. We have to determine distance between 2 points. So we represent first point as Px1 y1. Let us take its general form. What is x1 and what is y1? x1 is the distance of this point from y-axis, and y1 is distance of this point from x-axis. Similarly, the second point will be taken as qx2y2. x2 is the distance of this point from y-axis, and y2 is distance of this point from x-axis. This is nothing but this. Both are the same. And now we will find a triangle here. Can you tell me which type of triangle is this? Correct. This is the right angle triangle. So we can apply here Pythagoras theorem. What is Pythagoras theorem? The hypotenuse square is the addition of square of other two sides. Here we get one side. How can we calculate this side? See here, from this point x-axis, the point Q is 8 unit far from y-axis, and P is 4 unit long far. So x2 and x1. x2 is this total distance and x1 is this remaining distance. So we get here x2 minus x1 as this side. Similarly, here the other side of a triangle, right angle triangle, is y2 minus y1. So we can calculate here hypotenuse. So hypotenuse equal to square of this side plus square of other side. So we get here distance PQ equal to, means the hypotenuse equal to square root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Here this formula is called the distance formula in coordinate geometry. Now apply and evaluate. Now we will see how this coordinate geometry is applied in our daily life. Here is the problem. A person was standing at the position 3, 2. He walked to left for 8 kilometers, then turned to left and walked for 4 kilometers. Answer the following questions. 1 is to explain the situation, what scale you have to take on graph. Second one, in which quadrant he reached finally. Third one, what are the coordinates of this final destination? And fourth one, how far he is reached from its initial position. Now to solve this, let us take first scale. What is the scale? Here we are given that the distance is in kilometers. He walked first 8 kilometers, then for 4 kilometers. So, and here in the plane we have taken 1 centimeter square. So, we have to scale this graph for this situation as 1 centimeter equal to 1 kilometer. Now, the person was standing here at 3, 2. X coordinate is 3 and Y coordinate is 2. Now, as the given situation, he walked for 8 kilometers, means at left. So, this point is shifted 8 centimeter to its left. Then he turned left and walked for 4 kilometers here. So, he shifted downwards 4 centimeter. Now, we have to measure lastly he reached at third quadrant and its coordinates are -4, -2. So till this we get answer of 3 questions, sub questions. One is the scale, then where he reached, it is he reached finally at third quadrant, and its coordinate -4, -2, coordinate of its final position. Now for fourth question, we have to calculate distance between these 2 points. At initial position the coordinates are 3, 2, and final position the coordinates of are -4, -2. So we use here the distance formula. Distance PQ equal to square root of x2 minus x1 bracket square plus y2 minus y1 bracket square. We take the coordinate. So we get x2 is -4, x1 is 3, and y2 is -2, and y1 is 2. So we get square root of -4 -3 bracket square plus -2 -2 bracket square. After calculating this, we get square root of -7 bracket square plus -4 bracket square. The square of any positive or negative numbers is always positive. So we get square root of 49 plus 16. Finally we get answer root of 65. Therefore distance between these 2 points, that is distance between its initial position and final position, is root of 65. Therefore he reached at square root of 65 kilometers from its original position. So till this what we learn? We learn how to represent any point in the plane, and how to calculate the distance between 2 points. Thank you.